Alright, so let's continue with this thing right here. This angle, let's make up an arc. What do you think? Like, from here to here would be 90 degrees. So what do you think that is? Around 60, 70, something like that? Let's go 60 degrees. Okay. So what if this arc right here was 60 degrees and we want to find this angle? Well, the angle is what? It's half of the arc. So that's pretty easy. So what's this angle right here? Angle 2. It's 30 degrees. Easy. Now if this is 30 degrees, tell me something about it. This actually should go all the way to here. What is this angle 3 right here?
150.
Good. It's 150 because it's a it's a supplement of the whole entire angle. So if this angle is 150, tell me something about this arc. It'd be 300. Another way to figure out the arc would be a little easier. If I knew this was 60, then this is just the rest of the circle, right? So I could have got it another way. I could have just gone what? 360 minus 60. Do you get it? Because if this from here to here is 60, the rest of it is 360 minus 60, which is 300. We got it 2 different ways just to kind of verify that this thing really does work. Make sense? All right, that's all there is for that. Let's move on. All right, we have one more theorem, but this theorem has 3 different situations to this one theorem. So I'm going to draw a line, and what I'm going to do is I'm going to draw 2 tangents. Actually, let's just write this. I'm sorry. Let's go secants first. I'm going to go 2 secants. All right, and these 2 secants are going to intersect, but they're not just going to intersect anywhere. Before the 2 secants intersected where? That very first theorem. Where do they intersect each other?
In the circle.
Inside the circle, okay? So this time the 2 secants are going to intersect outside the circle, all right? So they are going to be secants, so they have to go through the circle, hit the circle at 2 places. Do you agree that's one circle, or that's one secant? Yeah. Let's draw another secant that intersects this one outside the circle, all right? So we might as well just start with that point of intersection right there. Just draw another secant like this. You follow me? Let's change the color. Actually, oops, I didn't want to do that. Let's keep it like that. Okay, now watch. Look at the arcs that they cut off. And I meant to make that red. I'm messing all up. Here we go. So watch. This right here is one arc cut off. Is that the only arc, though, cut off by that? Where's the other one? Way across here, isn't it? All right, so this one right here. Now, when we had the 2 secants that intersected inside the circle, it cut off 2 arcs as well, didn't it? Actually, it cut more than that off, but and here's other ones here, but these are the included arcs in between these 2. So, what did we do when they intersected inside the circle? What was the formula? It was half of the sum of the arcs, which means you did what to the 2 arcs? You added them up, okay? So when it intersected inside the circle, you added up the 2 arcs and divided by 2. This time it intersects where? Outside the circle. This time we don't add the 2 arcs together. What we're doing, by the way, I'm sorry, we're finding this angle right there, okay? So we'll just call that, I'll tell you what, let's make it a number. We've been using numbers, haven't we? So let's use a number. 10? No. We could use theta. Let's use theta. What the heck?
Oh, yeah.
All right. Okay, we'll use theta. All right, so this angle, let's not do that. Let's just say angle 1. I have no idea why. It's just I think on these they've been using number angles, and we'll just be consistent with what they do. Okay, so we'll use numbered angles. All right, watch. You guys watching now?
Yes.
So this angle right here is equal to not the sum of these 2 arcs. What do you think? It's the difference. 1/2 of the difference of the 2 arcs. So let's write. Let's label this. So A, B, C, and D. So watch. Angle 1 is equal to half the difference. Almost said sum. The difference of the 2 arcs. Now it really makes a difference. How I didn't mean that, but it does make a difference on which order you subtract these things. Am I going to go AB minus CD? No. I want to go what? CD minus AB. Why is that? Right, you'll get a negative, and I want the bigger one minus the smaller one. Okay, and it does make a difference. I want to do it that way. How do you know it's the bigger one? Just by looking at it? Well, look, if this thing keeps going off at an angle, guess what's happening? The further it gets, the larger that arc gets, doesn't it? So this has to be the larger arc, and this has to be the smaller arc. Okay, so what we're going to do is we're going to go CD, arc CD, minus arc AB. All right, and that's how you figure that out. Let's see. I don't know if they have any. they don't really throw you an example with numbers in here, but we can make something up, can't we? Tell you what. No, let's not make anything up. We don't have time. It's not that hard. You see what to do, okay? You just subtract the 2, you take half of it. It's no big deal. It's not that hard. All right? So let's go to the next one. All right, so we did 2 secants already. Now what we're going to do is we're going to do a secant and a tangent. And they're going to intersect outside the circle again. All right, so let me draw these real quick. All right, now we have, what, a secant and a tangent. All right, and look at the angle. Here's the angle that's formed right here. It's this angle right there, whatever you want to call it. Call it angle 2. All right, so this angle, now look to see what's being cut off here, where the arcs are. Well, from here to there, okay, and where else? Let's do that in a different color just to kind of... That's right, that's right, from here all the way until you get to where? What is that place right there? We give it a name. The point of tangency. Right, good. The point of tangency. Now those are my 2 arcs. They're 2 different arcs, aren't they? All right. So what I want to do, it's the same exact formula as what we did before. So let's just call this A, B, and C. But the thing is, we only have 3 points here, don't we? So angle 2 equals half of the difference of the 2 arcs it cuts off. That's why they put it in one theorem. Even though there's 3 different situations, they put it in one theorem because the formula is exactly the same. All right? So it's 1/2 of the difference of the 2 arcs. Now, again, which one is the bigger arc? CB. Minus the littler. Is that even a word? The littler? The smaller, how about that? The smaller arc, which would be AB. All right? And there it is. So again, you know, they're going to put numbers here, and you just plug stuff into your formula, and then you just work it out according to whatever they ask for. They could give you an angle and one of the arcs. They could give you both arcs and find the angle. All right? It just depends on what they're going to give you. And you should be able to just use this formula every single time and not have a problem doing that. All right, we have one more situation. Remember we said we were going to have 3 situations here. 1 minute, okay? Your teachers won't mind. Yeah. So let's draw a secant. There's a point outside the circle, and let's draw another secant right here. A tangent. Thank you very much. I was wrong. It's a tangent. Watch carefully. I want to show you this. Look at this. Look, cuts off the arcs. Look at this arc from there to there. All right. Don't leave yet, please. Don't leave yet, please.
I'm not leaving.
Well, sit down. Sit down. And then you've got this arc right here, don't you? So what's going to be true? We'll call this A, B, and we'll call this major arc, we'll call it C. So look what we have. This angle, we'll call it angle 3, is equal to what? Angle 3 is half of the sum? The difference. So what's the biggest arc here? How would I write that? A, C, B. Minus what? A, B. Alright, there it is. Let me give you your homework. Your homework is 732. Numbers 8 to 23. Alright, see ya.